Hello and welcome to another video. In this video we're going to be working on count subarrays with fixed bounds. And in the problem you're given an array nums and two integers min k and max k. A fixed bound subarray of nums is a subarray that satisfies the following conditions. The minimum value is equal to min k and the maximum is equal to max k. Return the number of subarrays. And contiguous again, so we're looking for a sliding window most likely. So for this they show you which ones there are, and for this there's 10. So this is like every single subarray in this is going to satisfy this. So let's take a look at an example. We just have a bunch of 1s and 5s and a 7, and we're looking for subarrays with a min of 1 and 5. So it's pretty easy with brute force. Brute force, you just start at every index and you just grow this out. And anytime you hit a number outside of this range, so if you hit a number that's greater than 5 or less than 1, you can just stop. Because for example for this, if we keep growing this out, we will never have a max of 5 if we have a 7. Similarly, if we have like a negative 5 in here or something, we'll never have a min of 1 if we have that. So that part's pretty easy, but how do we make a sliding window solution? And the problem here is, like, let's say we just have a valid window like this. How many subarrays are there that end with this index? Like, it's kind of hard to say because it actually depends on these numbers. Like in this case, there's, let's see, so this is valid, and this is valid. So there are 3. But what if this was like a 3? Now this is not actually. So this would still be valid. Yeah, but so I guess for that one it would be fine. I guess it would like depend on more or something else. So let's say it was like this. Like this is valid. But if we shrink it, now it's no longer valid. So it depends on the numbers in here. So just because you have a subarray doesn't mean you know like how many, or just because you have a valid window doesn't mean you know how many subarrays there are. And for that problem, so what we kind of did yesterday was we split this up into 2 parts, and we're gonna do a little bit better of a solution now. So instead of having a normal sliding window, we will also keep track of one more pointer. So we'll have the minimum valid window and the maximum valid window. So min valid, max valid. And you can actually use this to solve earlier problems that we did, but for a lot of earlier problems it was like let's say we have some window like this that's valid, then we said like, okay, well if this is valid then all of these are automatically valid, and we already know that. But in this case we don't, so we're actually going to have a third pointer to keep track of like the min and max valid window. And then if you have 3 of them, so for example let's just say like the min valid window is here, and the max valid window would be like here. So what I mean by that is like this is the minimum, this is the maximum. And then the number of valid subarrays is pretty easy. It's just going to be the difference between these 2 indices plus 1, right? So like this is a subarray, this is a subarray, this is a subarray, this is a subarray. So we're going to use these 3 now. And I'll kind of walk through exactly what we're going to do and so on. So let's start at the start with 3, and then we'll have a result. And then I'll talk about how to optimize this so you don't actually need to like grow and shrink. You can actually do this a little bit faster. Just like for code wise, it's going to be a lot easier. So, but that's only like related to this problem specifically. It's not like a template. So we'll go over the template that you can use and then just how to simplify for this one. So here in the beginning, like we don't have anything. We only need to shrink our subarray when we actually have something valid. So like right now, we need to have at least an array with a 1 and a 5, and we don't. And the min needs to be 1, the max needs to be 5, so we don't have that. So we're going to grow. Now we do have a valid one. And to shrink it is pretty straightforward. To shrink the smallest possible, we basically just need to make sure like we need to be on a 1 or a 5. And then we just check like, is this the last 1 or 5? If it is, we can't shrink it. And if it isn't, then we can shrink it some more. And if it's some other number, we can just shrink it. So in this case, we can't shrink it, right? Because this is being valid. So here, our min and max window are the same. That means we only have 1 array. Okay, so now let's grow this out. So same thing here. We can't shrink it because then we need to have the 1. So notice how like in order to have the window be valid, you actually need the 1 and the 5. So here we only have 1 array as well. We can't shrink it. So now we can shrink it because we have 2 1s. So we are allowed to shrink it. And we can just keep track. Like all we really need to do is keep track of these 2 elements, the 1s and the 5s. And everything else doesn't matter as long as it's in the range. As long as everything else is between these, it's irrelevant. And if it's smaller, I'll show what to do there. And if it's bigger, I'll show what to do there. So here we can shrink. So we have 2 1s, so we can shrink. We have 2 5s, so we can shrink. And now we can't shrink anymore. So now this is the min window and this is the max window. And the number of subarrays is just the difference between the min and the max plus 1. So there's 3 here, so we will have 5 total. because like this is a valid subarray, like this one right here. This is a valid subarray, and this is a valid subarray. So we can do this in O1. Okay, now we get to a number that's outside of the range. So if we get to a number that's outside of the range, any window with this number won't work. So now we can just say like, okay, well, like we can, like this is kind of like a break. So we can treat this as almost like there's a break here, and like anything here is not going to work anymore because we can't include this number. So we can actually take our min and max pointer and just move them to the one past it. Because like this is no good, and then now we go over here. So we can just move all our pointers to the next thing. Okay, so now this is not valid, so we grow. Now this is valid, we can't shrink, so we have one more. Now this is valid, but we can shrink because we have 2 1s, so we can shrink. Now we can't because we only have 1 5. Okay. And now how many subarrays? So there, like I said, the difference between the smallest and the biggest window. So smallest window here, biggest window here. The difference is just 1, and you can literally just do this number subtract this number. Sorry, it's this number subtract this number plus 1, right? Because there's 2 subarrays. There's this one and this one. So 1 5 or 1 5 1. So we have 2 here, so 8. Then we grow some more. So notice like the biggest window possible stays the same. Like this location stays the same. And then anytime we get to a number that's out of bounds, then we just update it to a new starting location. So the starting location stays the same, and then we just keep shrinking our middle one. So here, we can't shrink it anymore because if we get rid of the 5, then this is invalid. So for this end index, we can't shrink anymore, so we have 2 more here, so 10. And here, now we can shrink because we have 2 5s, so we can shrink. And we can shrink again because we have 2 1s. So the smallest is this, and the biggest is this. The difference is 8 minus 5 plus 1, so 4 more. So 14. And like I said, this is valid, this is valid, this is valid, and this is valid. Yeah, I drew that a little bit weird, but yeah, so 2, 3, 4, and 5, all valid. And so we have 14. So to simplify this code a little bit further, notice that we basically have a couple conditions. Like our initial pointer, like our big window pointer starts at 0, and anytime we get to a number that's outside of the range, we update it, right? So like when we get to this number, we're just going to update it to the one right past it. So what we can actually do is we can keep track of this, and we can also keep track of, instead of having like the right and left of the window, we can just instead of keep track of the last 1 we've seen and the last 5 we've seen. So let's briefly go through that, and this is going to make it simpler for the code, but this doesn't work for all problems, it just works for this one. So here, the last 1 we've seen is now going to be over here. And basically we know our window is valid when the last 1 we've seen and the last 5 we've seen are both past or equal to the starting index. So here, the last 5 we've seen, we can just initialize it to be like -1 or something. So we can initialize both the last 1 and 5 to be -1. And then, so here, the last 1 we've seen is over here. We can just keep track of that index in a variable. So these 2 will just be variables, like last 1 seen, last 5 seen. And this is like last min k seen, last max k seen. So here, because the last 5 seen is not past the start, we don't have anything valid. So now we go over here. And sorry, we don't actually move our start index. So we are going to be traversing, like we are just going to loop through these, but we don't move our start index. The only time we move our start index is when we get to a number that's outside of the range. So our start index is just going to stay here. So the last 5 we've seen now comes over here. And now basically the small window, like the smallest window possible is so if we have like the location of the last 1 we've seen and the last 5 we've seen, it's going to be the smaller one of the 2 numbers. Because we need our window to include both the 1 and the 5. So the location here is going to be this location here. I can actually show those in different colors too to make it easier. So let's say our min is green. And yeah, so the last 1 we've seen, let's say it's 5, and the last 5 or last 1 is green, and the last is like this. So yeah, so we basically just do the minimum of these 2 minus this value over here plus 1, because that's how we can keep track of the window without actually like shrinking or doing anything at all. So it's just going to be 0 minus 0 plus 1. So here we have 1 window. Okay, now we keep going. Now we go to this element. So this is a 5. So we update the last 5 we've seen to over here. And we do the same thing. We take the minimum of these two minus where our start location plus 1. So this is just 1 again. So this is 2. Now we update the last one we've seen to over here. Once again, we take the minimum minus this. So this is 2 minus 0 plus 1. So we have 3 here. And this is just going to like make the code a lot easier. So, and this makes sense, right? Because like we are at this index currently, but our smallest window is always going to be the maximum or the minimum value of the last one we've seen and the last 5 we've seen. So our smallest window has to be from here to here. And then our biggest window is always just going to be like our start pointer. That doesn't move until we get to a number that's out of bounds. So now what we do is we get to this 7. And now we can say, okay, well, these are invalid. But we want like our check for a valid window will be our 2 pointers for the last 1 and 5 or the last min and max to be greater than start. So what we can do is we can say like, okay, we've hit a 7. So we can just move our start over here now because our new start is going to be over here. And now we don't have a valid window because these are both below the start. So in order for it to be valid, these have to be both past the start. So now we come over here, and remember the last one we've seen is the green, so we update. But the last 5 we've seen is still below, so we don't need to do anything. Then we come over here, and here's a 5, so we update the 5. Now we have a valid window. Remember, we take the smallest one of these minus the start plus 1, so we have 1 here. Hopefully I did like the math right, but this is kind of like what it works. Maybe I screwed up a little bit. So now last one we've seen, we update to over here. Take the smallest minus the start plus 1, so this is 2, so 8. And like I said, this is relevant to this problem. This isn't going to be like a generic window, but you can use it for this problem. For a generic window, you just take the smallest window possible and the biggest window possible, and you subtract those 2 indices. That is possible. Okay, so last one we've seen, we update to here now, but this is still the same, so there's 2 more here. So 10. And finally, last 5 we've seen is now going to be over here. Take the smallest one of these, because like I said, the minimum window is always going to be the first one of these 2 up until our current index, so it's going to be that window here. So you take this window minus this plus 1, so we have 4 elements, so 14 total. Hopefully I got 14 in the last one. If I didn't, probably screwed up with the pointers at one point, but that's basically how you do it. So the generic strategy is you have a 3 window, you have the smallest window possible and the biggest window possible, and then you just look at the difference between those 2. We didn't have to do that for the medium problems because the big window was kind of like obvious. Like it was either, you know, we kept track of the big window, or the big window was like the small window was here and the big window was everything past it. But when it's not some super obvious thing, you just have 3 pointers instead of 2. And that's how we do it. Okay, so we can code that up in Java using our shortcut solution. So we're going to keep track of the last like min k scene and the last max k scene. So let's say like last min, and then we'll make these both -1. So int last max. And remember, our valid window will be when both of these are past our start index. So our start index, or like the left side of our window, we can call this left if we want, or L even, we'll just start at 0. Then we loop for the right, so we can say for int. So the right isn't, yeah, actually, no, the right will be the right side of the window. So this is going to be right equals 0, right is less than num's length, all right, plus plus. So first we can check if the current element is out of range. So if the current element is less than min k or greater than max k, we're just going to take our index and then move our start to the one past that. So we can say if nums right is less than min k or it's greater than max k, we can just we know like we have to make like a chop here and we have to take elements after it to consider, because this element can never be valid. So if this is greater than max k as well, then we can just update our start. So start equals right plus 1, and we can just continue here like there's nothing else to do. Okay. So now what we need to do is we need to check if this element is either min k or max k. If it is, we need to update these 2 locations. So if nums are equals min k, then we update our last min. So this is going to be last min equals nums right. And then we need to update our other one, and they might be the same, so you don't want to do like an else if. So if num's right equals, double equals here, max k, then we need to update that one as well. So last max equals num's right. Okay, now we can just check to see if we have a valid window. So the left side of our window will be the start. So basically the left side will be the start and the right side will be the start. Or not, sorry, the right side will be the minimum of the left and the right. But we have to make sure, remember, we have to make sure that both the min left and, like let's say they're over here. We have to make sure that both of these are past the start, so we can check for that. So we can say like if last min is greater or equal to start, and last max is greater or equal to start, then our window will be, so we can have a result for that. I forgot to initialize. Equals 0. So we can say result plus equals the minimum of these two. Remember, if both of these are past the start, the smallest window we can have needs to include both of these elements, and these are the last ones we've seen. So but if we need to include both, we need to take the smaller index of these two. So this is going to be the math minimum of these two. So last min, last max. And we need to subtract start plus 1, right? So as an example, let's say these are both past it. So basically our smallest window would be this, and our biggest window would be this. So anything within that works. So like this works, this works, this works, and this works. So we have 4 elements, and that's 8 minus 5 plus 1. So yeah. So we do that, and then finally we return the result. So this is like the simplification to make the code pretty good. And let's see what we screwed up. So we don't have a start, looks like. Oh, it's because I used L. So let's just rename start with L. Okay, let's see if that did anything. Maybe. Yeah, let's take a look. All right, so our problem is we shouldn't be storing like the number, we should be storing the index. So these should just both be, or not nums, but R. And I think that should do it. So let's take a look. Oh, still got problem. Oh, so we need this to be a long. So at least this is kind of obvious in Java when your number's too small or something. It's like almost always the case. There we go. Okay. So this is like a generic thing you can use now. Instead of like this, just have a 3-pointer sliding window where you keep track of the min and max window. And like I said, you could have technically used this for all these other problems with the subarrays, but because for that one, we only could keep track of one and calculate the other on the fly. We didn't need to keep track of the other. But this is how you would keep track of both to then figure out how many there are total. So definitely something new to me as well. So, but something you can use in the future. So here the time is of n and space of 1. Or alternatively, like I said, you can just break this down to multiple sliding windows. I think I even did a problem that you had to do a sliding window for like every character in the alphabet. Obviously, you can't do like the 2 thing there. But yeah, like if you do need to run a sliding window multiple times, that's also fine. So those are like 2 tools you can use now: a 3-pointer sliding window, or just run a window multiple times. So that's gonna be all for this one. Hopefully it was helpful. If it was, please like the video and subscribe to the channel, and I will see you in the next one. Thanks for watching.